In this video, we are going to analyze dataset from 0 to hero. We're going to analyze dataset from 0% to 100% using STATA. So feel free to stick around. I'll take you through step by step how I always do if I am working for my clients. How I always analyze the dataset, what I always look into within the dataset, and then how do I clean it up, how do I perform the analysis to fit the objectives, which commands do I use. So in this video, we are going to do we are going to do descriptive statistics for our dataset. We are also going to do the bivariate analysis, the chi-test, that will include the chi-test, a binary logistic regression. Then we shall do a multivariate logistic regression. Those are the 4 analyses we are going to do. Now, this is the raw data. I think in later time, if I create a database, I'll upload this, then I'll put the link in the description if you want to. But you can use any data set you have. Now, the client gave me this data set, like it was that heavy. Let me open the original document and I show you what the study was about, what the research was about, so that you have a clear idea of what we are dealing with in this case. So it may be your research. Maybe if you're collecting your data, you could be having your data available, or you're about to get data set. So these are the things you will go through. These are the following questions you need to be asking yourself. Now, so if I look in here, the title for this project was a community diagnosis report of a selected village. So generally it was a survey. This was being done by students doing medicine. And so they're supposed to go to community, try to carry out a community diagnosis, just generally to find what are the most common challenges health-wise the community people are facing. Now, their original objective was really broad. Like they had so many objectives. They wanted to assess communal and non-communicable diseases, risk factors associated with the respiratory tract infections, peptic ulcers, urinary tract infections, among others, immunization uptake, attitude of community towards family planning, and nutrition status of children, and then establishing sanitation, water and hygiene status. This was the original idea. And what they collected, this was a raw data set they really collected, and this was in Excel format. So it was really broad. They had all these interviews, total of 86, and then all these questions were asked and the responses were given. In total, this had about 99 columns that was collected as raw data. And so they just gave her like, here it is. It was up to me. Now, even if you look at this raw data, it had so many issues associated with it, so many errors associated with it. Okay, others I corrected it already, but you have some redundant information. For example, this was education level. Now you have university, and then somewhere you have where okay, secondary O level, secondary A level. That's within a similar category. University, then others you have other tertiary institution. Never attended school, primary, secondary. Like there are so many subcategories. We could group tertiary together with the universities all at the same time. Then secondary or an A level, all that is secondary level of education, can also be grouped all together. Primary, no education. Why? Because the fewer groups you have, the more you can have results that make sense and you can explain them. If you have so many groups that are like cross divided, it becomes tough. And also it depends on what you are dealing with. If you're doing a survey and like making all these excess groups are not going to be very, very important in the output, then is the fewer groups you have, the better. Now you look at this example here. This is a marital status. So you have single, separated, married, widowed, divorced. Now, single, somebody who is separated is single. Somebody who is divorced has also remained single. Somebody who is widowed has also remained single. So let's say this, you could even regroup it into married, single. It's not important for us to go deep into the details of single what? Single, did not marry, or single, widowed, or single, divorced. As long as, like, does that information give us any important context as far as community diagnosis is concerned? Is it that important in relation to community health? No, it's not. Unless we're dealing with something, let's say HIV kind of thing, then you want to know, okay, HIV prevalence amongst the single versus the married versus the divorced, it is a maybe. But if it's not, then it's better to really group some of them up. Things like religion, instead of having Muslims, Protestants, Catholic, born again, others, I could have Christianity, Muslim, or then I add another most common group, so that you have fewer categories, and you're able to really have this explanation in here. So so this is what you'll always face, and some of you students, or some of the students that will give you that work, they will be having this redundant information in there. So talk to them, they can regroup it. So what did I do? I cleaned it up. I cleaned it up, like, to really have these fewer groups as much as possible. And also, on talking with the supervisor, because these are so many objectives, their supervisor advised them to only stick with this objective, to assess the risk factors associated with the upper respiratory tract infection only. The supervisor removed everything, including these peptic ulcers, disease, urinary tract infections, and etc. This was like too broad. So you may be having a study related in that category, whether social science, whether in any category. You could be dealing with factors associated with stress amongst workers working in a given bank, or factors associated with poor nutrition amongst children, or you could be having any of those studies in that category, or even if you're in that category. So I clean this data so that I only have data set that fits to assess the risk factors associated with the upper respiratory tract infection. This was the updated data. So I only remain with the age, gender, marital status, religion, never attended school. And if you look at marital status, as I told you, I changed everything. I only remain with the married, single, married, single. Those are the groups I really needed. Education level, all the university, I removed and combined it together to make it tertiary institution. All the O and A level, I combined to make secondary education. Then employment status, I also grouped them in there. Occupation, I adjusted it. There were so many subcategories. So I also changed it. Number of people home, blah, 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 etc. Child's diet, I adjusted it. And then the most important part is this last one. Second last question was, have your child been sick? Then the question after that also is that currently, is your child having respiratory tract infection? Now, this was recorded as yes, no, yes, no. I changed it into 0, 1, 0, and 0 is meaning no, 1 is meaning yes. Because our outcome of interest is, did the child have respiratory tract infection? Something like that. Now, when you're going to do a logistic analysis on STATA, I will explain to you why this is important. Now, let us jump into our STATA software to now analyze this data set. It's now clean and all that. I always tend to clean it in Microsoft Excel. It's much more easy. Now, let us import our data set. So the first thing I always do, if I open my STATA software, I do importing, of course. So import, go to File, come to Import, import Excel, go to Browse to choose the file, look for where your data set is, open, come to the worksheet number, ask yourself which position is the worksheet. This worksheet was updated. If you go to Excel, you see it is under updated. This is where the one I want. So you choose that worksheet. If the worksheet has only one page, there will be nothing to choose. So Now it had column title, therefore I'm going to import first row as variable names. If I don't click, you see my column is going to be A, B, C, D. But if I want the column title that is in my Excel to be the column title in my STATA software, I'm going to click import first row as variable names, so it has imported it. Then I press OK. Now it has opened the data set. Next, I need to encode this data. Okay, let me first check its cleanliness. So I can check its cleanliness. The first thing I can do is okay, codebook. Codebook is the first command I can use just generally to see. It gives me a general summary from one variable to another. This is numeric. This is unique values are 33. The mean standard deviation because it is numerical. Then gender, it's recorded as a string. The type is string. There are two categories. Unique values are two. You can see the details in the male, female, etc. So you can do code book, and you can be able to see are there missing values or not in that data so you can be able to see some of that information. Now, having done that, you can do by the BR, browse, to go and visualize how your data is looking. If you do BR, I always do BR. If I go and see browse, I can see that, okay, every data set is here available. If you see black, everywhere that data set is black, that is a numerical data, integer, black, okay. So the software has recorded it as numerical, black, numerical. If you see red, those are strings. The software has recorded as a string variable. Now, what you need to notice that whereas you can work with some strings under STATA, you can work with the strings. You can do things like tabulation that we're going to do. Some other analysis cannot like accept if you're having string data. We will see. Let me just give a simple example. You can do a tabulation of, let's say, gender, and you can get an output like the frequency for the males, females, and their percentage. That could work, right? That could really work. But if you do let's say you want to do logistic of, let's say, the dependent variable having RTI, that is a respiratory tract infection. Then you want to do an integration with the gender. You can see the error here. It is a string variables, so it may not be used as a factor variable. So you will not be able to do a logistic regression analysis because of the string. Therefore, you will need to convert the strings into numericals. It is called encoding. So as soon as I import and I do codebook, the first thing I generally tend to do is to do encoding. I look for every strings, then I convert it into numericals. Now, from my data set, age is already okay numerical, so I don't need to. So I need to begin converting from gender up to people home. Then I again leave how many children are there at home. Then I progress onwards. So let us encode. So encoding is a command in STATA which helps to convert string variables into numericals. So I do encode. I choose gender, comma, generate. Because you're converting string into numerical, you need to generate a fresh variable, a fresh column, a fresh data, something like that. So I'll generate, now this time around I'm generating a new column which has numerical data set of gender. So I'm going to then put here gender. It cannot go with the same name. If I put capital G, it will not accept because the name has to be slightly different. Note, if I click enter, it has recorded. If you come on the right hand side, I can see that it has created a new variable with the name gender. And if you browse BR, you can go and check, and now it is in blue color. Now, blue color is in STATA. Those are numerical data which has string names, sort of like that. It has character names. Behind the scene, it is a numerical, but what you're seeing, it is a name for all those numerical data sets. So it makes it in blue. It means that those characters have a numerical attachment value assigned to them. So I need all my reddish to be bluish. There I will be sure. So next, let me encode the next. I encode marital status. So this is going to take long. I'm going to rush through the video so that we finish encoding all the numerical. So let me finish it up. Okay, so I'm now done performing that encoding. So if I browse, I can now see that on top of this reddish one, if I go on the right hand side, I have all these bluish kind of data set. So those are the ones that I'm done encoding them. Why should I encode them? It is because I want to then use it in further analysis. Now, I therefore need to drop everyone that is string in here because it's not important. So I drop all the ones that are string because the copy is already created. So I'll drop gender, their strings, marital status, religion, education, employment status, occupation. People at home, those were numericals, so I will not. Children, home. Okay. And then occupation. Okay, I don't need that one. Okay, that one is already dropped, so let's it remain. Child underlying condition, if yes, specify smoker, child under pressure. So I remove all these variables and I stop. I don't remove half HRT. If I click enter, it has removed all those variables. If I browse, is there any I've missed? Okay, I've missed people at home. Let me drop that one. Okay, let me also drop that one. So when I browse, I can now see that I have only bluish and then the blacks, which are numerical. That is it. Now, having done that, I now begin doing descriptive statistics. So let us perform descriptive statistics on this data. Generally, I want to get the mean age of the people. That was 36.86. Standard error is 1.6. That is okay. You report in your data set. You can then do tabulate gender. Okay. Tabulate gender, that is okay. It will give you that frequency and percentage which you will need to report. Again, I tabulate marital status. You'll be having a data set tabulate. So you tabulate all these other categorical variables so that you're able to have its statistics available. So I tabulate child with underlying condition. You keep tabulating. So what it does, it will give for you the frequency of the responses and its percentage, or what you call a proportion. I do that. Child fed on vitamin. Has a child ever been sick? Yes. Then I can also now tabulate my dependent variable. Is the child having respiratory tract infection? Depending on what your study is, so you can then choose that, and then you can see that, okay, that no, 0 means no. So 24 of the children, 24 out of 73 of the children didn't have respiratory tract infection, and then 49 had it, and these are the percentages. Now, whereas we could proceed from here, this dependent variable are again recorded as 0 and 1s, and sometimes if you run the analysis, it is really hard to interpret. Why can't you name this 0 and 1? You give it a name so that you have yes, no, but yes, no in terms of, again, numerical data. So how do I convert 0 and 1s here to have yes and no? Okay, now that is called labeling value, label value. So there's what we call label define. Label define. You need to label define. You tell them that I want to label define. You create a label name. So I want to label define, let's say DS. That time you give it, you can do anything. 1, 2, 3, 4, DS, any character. You're just giving it a title of a label definition. So I want everywhere you see 0, let it be no or not infected, or maybe healthy. It depends on your choice. Let me call it not infected. space. How about 1? If you see 1, make it infected or sick, something like that. That is my label definition. Press enter. You need to put it in quotes because now you're more like giving it like a character. So where there is 0, give it this character. So those characters need to put it in quotes. That is how. So we have defined DS. Now we need to apply this DS into our dependent variable, which is having RT. Therefore, that is called label value. So we want to label the value under have RDT, and we are going to label it using the key, which is found under DS. So you do label value, what you want to change, and then the key. Press enter. It has labeled. If you want to prove it out, you can do tabulate, have RTI. You can now see it has changed all the zeros. It is now not infected. All the ones are infected. Even when you browse BR, you can even see in your dataset it's no longer 0 and 1, 0 and 1, 0 and 1. It has converted it into now a character based, but it is blue in color, telling you that behind the scene, all these characters have a numerical attachment value attached on them. Good. Now, having done that descriptive statistics now, I go ahead and begin doing a bivariate analysis. Let me begin with a chi-test. Remember, the objectives are to determine the risk factors associated with somebody having respiratory tract infection. So all these other variables here are contributing factors, they are risk factors. But how can you then assess whether those risk factors are significant or not? So basically, let me begin with a chi test, which will be a test to show me whether the distribution of my value of interest, that is having respiratory tract infection, is it normally distributed, like is it distributed uniformly, or it is skewed, like some people are having more or not, like is it distributed, is it of a significant importance? Is there something we have to worry about? Is there a group? Is there a factor which is contributing more? Sort of something. It's more like a distribution, frequency distribution. That's what chi-test does. It doesn't offer you that real direction, but it gives you an insight that this factor and this factor may be significant. So some institutions want you to do, some other institution doesn't want you to do. So this step depends on whether your supervisor wants you to do or not. So chi-test is gotten from a 2x2 table. It's a 2x2 literally table. So literally I can just do a tabulation of gender versus it is 2x2. So I have the independent variable versus the dependent variable. If you only stop here, this would be a normal 2x2 where you'd only have a distribution of gender versus your dependent variable. But this table, you can modify it. You can say I want raw percentage. You just put comma, add raw. Those are what you call options. So on top of giving you frequency, it also gives you the raw percentage. That okay, amongst the females, 21% were not infected, 78% were infected. Yeah, but also on the same one, you can add, you can let it give you chi. So if you add chi, it will give you a chi value, right? It will give you a chi value in here. So this would be now our chi value to use. You can literally also do tabulation, independent, dependent, and then you just put here all. If you do all, it's going to give you these statistics here, Pearson, likelihood, all these other statistics. Or you can do tabulate gender, blah, 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 raw percentage, all, and then this one would be in terms of percentage, and then you have the chi value. But from experience, most of the supervisor would only want you to report frequencies and then the chi values. So I just do tabulate, independent, dependent, comma, chi. So you'd be able to have frequencies, their distribution, and then Pearson chi value and the p value. Is it significant or not? So we can see this is significant. P value is less than 0.05. By default, STATA will be doing analysis at 95% confidence interval. So significance will be concluded if you have probability less than 0.05. So that is a fair sign. But here we cannot tell that which of these is a contributing factor, being male or being female. We can't tell in this case. But let's finish up those ones. So again, I'm going to fast to fast forward the video, but literally all you're going to do is you run all these independent variables one by one, and then you do a chi value. So you will be able to get all that chi input. You do tabulate, we are now going to religion, do having a respiratory tract infection, comma, then you add the value chi. It will always be giving you that information. Then you'll be able to report that one accordingly, and it has respective p-values in here. So let me just run that first. I already created a do file. Okay, let me just run that first. Okay, so we're done with the chi tests. It has gone through all these we have done through for each and every independent variables in here versus our dependent, which is having RTI. And we can see the p-values here. They are really more than 0.05. Oh, this is child's diet is also less than 0.05. So child's diet alongside gender, they are significant. Having taken vitamin is not significant associated. This is also significant because it's less than 0.05. So has your child ever been sick in some previous month? Yeah, so that those kids are also significantly, they're more likely to have respiratory tract infection, maybe because of the immune system has gone down one way or another. Now we're done with this one. Now we have to take it a notch ahead, and then we do some logistic regression. I get some odds ratio to look at which group had more likelihood of having the infection compared to their counterparts. So the command you would use here is logistics. Logistic, and then you would choose your dependent variable, and then the independent variable you want to regress with, and then before that independent variable you add the I dot logistic, your dependent variable, your independent variable, then add your I dot to stand for like to tell you to do a logistic regression, like on that, like something like that. And so if you run, it's going to produce for you this output, and it will give you this odds ratio, which is very important. Let's say you did not put this I. Let's see, would it run? It still would be able to give you something, okay? But that would of course be a risk factor in there, yeah? Because if you look at these values are a little bit different. The down one, though, is not important. The upper values which are up here is the most important thing. But the challenge is that it does not give you a category. Look at up here. We can see that female is hidden, but male is here. Let us first interpret this up one first. This up one means that what if you're running a logistic regression, STATA is going to pick one of the response to act as a baseline for you to compare one against. Here we do conclude that male children are 0.165 times less likely. The standard is 1.0. So by default, the value which is picked to be the reference is given odds ratio 1. So by default, in this case, female is taking odds ratio 1. And now we are comparing male against the female towards the likelihood of getting infected. So here we can conclude that male children are 0.165 times less likely to get respiratory tract infections compared to their counterparts who are female. And here is the probability. It was significant. So it is a significant variable. Like gender is significantly associated with having respiratory tract infection. But if you run a command logistic and then you do not put I dot, look at what it does. It only gives you a plain value. It does not separate for you what are you comparing against, male or female. It is hard to tell in that case. Let us try something else. If I do logistic and then I do marital status, let me get something with more than one category. Let me do education and then having respiratory, I need to begin with respiratory tract infection first. So I first begin with the respiratory tract infection. That's the dependent. And then you do education. If I do add I here, okay, it goes through, right? Everything looks to be okay. But if I remove, so here I can easily see that, okay, primary, never attended school, tertiary, there is no secondary. So secondary in that case is now the best and we are comparing against. So in this case, I would say people, children with the parents who have reached tertiary institution are 0.21 times less likely to have respiratory tract infections compared to their counterparts whose parents only have secondary level of education. Children from parents who had primary level of education are 1.14 times more likely to have respiratory tract infections compared to their counterparts whose parents had secondary level of education. That would be a conclusion. But let's say that command had run without an I. What would happen? Look at what it does. It only gives you a uniform kind of value. In this case, you cannot draw conclusion based on this. So when you're going to run this analysis, make sure you have I somewhere there. There is also another version of running this analysis. I think it is logit. Logit, and then I put, let's see, I hope it works out. I put my dependent, I put my independent. Then you need to add odd ratio. Let me check it here. But it should be able to have taken a long time. Sorry, I've taken a long time without running logit. But I say logit dependent variable. Okay, and then you need to add independent variable, and then there are options. Let me see the options in here. I want an option of regression. Okay, so there is OR. You need to add OR to report odds ratio because I need odds ratio. Okay, so in that case, I'll do logit. Our dependent is having respiratory tract infection. Let's say education. Then you put comma OR. Okay, it has still given a similar thing. So I think in that regard, there is no hope. And I know that with the logit, still I may need to put I there. So you cannot run away from I. I think what is special with the logit is that if you use logit and you don't add this option OR, it doesn't report for you odds ratio. It reports coefficients instead of odds ratio. So the option for dependence, then you have an I in before the independent remains constant for both logit or logistic. But if you use logit and then you run logit only, you will not be able to have odds ratio. You'll have coefficients only. But if you want odds ratio, then you need to add comma or R, and then it will report for you the odds ratio. But alternatively, you'd rather than have here logistic, and then you have dependent, independent, then you remove this OR, it will give you the same output. So that is another version in there. So that is what I'd be. I'd run logistic regression for all these dependent variables. So let us fast forward on that. So logistic regression, we are now, so you just do all those logistic regression one by one. Of course, this one I already perform one by one. So you'd be doing this one by one by one for all the variables. Now, I will need to then do multivariate logistic regression to remove what you call the confounding factors. How? Let me explain that. Although we are saying gender is associated with the respiratory tract infections, apparent education level is associated with it. But so you realize that by the time you have that infection, you may be having multiple factors that may contributing you to having that infection. So all those factors, we call them the confounding factors. So we are saying that it is hard to draw conclusion that gender is really a significant factor, or whether taking vitamin is a significant factor. Therefore, you need to do what you call the multivariate logistic regression, so that you're able to rule out every variable that may not be a true significance. Now, there are rules for doing multivariate. There are rules upon it. But I'm not going to talk about it in this lesson. But you're supposed to have, like, you only cut off from a certain p-value. But in this case, let's drop that off. Let us say you need to run logistic for your dependent variable. Again, it's all other variables, all other independent variables, everything from gender, marital status, religion, education, employment. Okay, how many people do you have at home? Is the child having underlying condition? Is there any smoker? Is the child going to school? Does the child use public transport? Does the child have good diet? Does the child take a vitamin? Has the child been sick? I want to do this, what called a multivariate. Now you consider all the independent variables at the same time. In this regard, you then need to regress. So I'm going to be regressing this against, so you need to be adding I against that, against that. So you be adding, so that you get odds ratio for all these variables. Now the difference is that the odds ratio from here, it is called adjusted odds ratio. Adjusted odds ratio. If you do a bivariate, you call it crude odds ratio. This is adjusted. Now this adjusted is much more preferred, is much more reliable now, because you consider all the variables at the same time. So any significance you get from here is now a true significance. Now let's run that. So when you run it, it will give you an output in one table. So it has not compared everything at the same time, and it has still given you the odds ratio. But in this case, the values are now somewhat different. Now let us confirm. Remember when we did bivariate, we said that gender was significant associated with the infection. Now look at what's happening here. It's not. In reality, it's not. If you go back to a bivariate, let us run a bivariate again. Remind ourselves. Logistic, I want to run having tract infections and gender. Then I add that. Now if you look at here, at a bivariate, it is significant. P-value is less than 0.05. But at multivariate, p-value is not. So meaning gender, in truth, gender is not a significant variable. So you're supposed to run multivariate analysis. Marital status has now become significant. This is less than 0.05. So marital status is literally significant to a child having respiratory tract infection. But let's see, how about if we are done only at bivariate, would it be significant? Let's see. Logistic, then we have that marital status, and then I put here I. Look at that. It's not 0.058. This is greater than 0.05. So marital status at bivariate is not significant, yet at multivariate is significant. So this is a true significance. So that is what I did on this analysis. So this is what I've performed now. This is everything that I've done within this analysis, and it has come to the end. So the client wants the output. So lastly, what do? One, I keep all the records for the commands I've run in a do file. So I copy all the commands I have, open a do file, and then save. All the commands I've been running will appear there. Then I edit. That one I keep it just for future use. Now, so it is well saved somewhere. It's where I was picking some of the commands from. So you keep all the commands you have run in a do file. Then next, if the client then wants me to give them the output, and then they write the write-up, I just come here, open a log file, begin a log file, then I say your analysis, for example, and then I need to run the analysis, of course, for me to be having that output available. So in that regard, I should be able to run all the analysis afresh. Okay, where you? So you run all the analysis afresh. So let me just copy all these codes. Okay, then since I've opened already my log file, so you just run all that, and then it will run for me the analysis. It will keep all this analysis because I've already kept the codes I've used. All this will be automated. So I can now come and I close off my log file. And if I go to where the log file is being kept, so it is here. Your analysis, it's there. If you open it, if you happen to open it with the STATA, it should be able then to give me all the output. Now this, I will then share it with the client. It has all the output for whatever I've been running. Codes are hidden. On that, this is a black screen. So this is what I'll share with the client. And with that, I'll be done with the analysis using STATA. The client is happy, everyone is happy, and I'm convinced. So thank you so much, and see you next time. Make sure you can follow up, apply it in your study, and you'll be good to go.